Hi there. We had been talking about scatter plots, and now we're going to talk about what's called the line of best fit. This is going to be a line used to describe what our scatter plot looks like, whether it's going up, as if this one is, or if it's going down, or if it's sort of flat. We're going to look at how we find that line. So first off, definition, a line of best fit is a line used to describe how a scatter plot looks. As I said, our scatter plots can go up, they can go down. The more closely grouped our points are, the stronger the correlation it is, and also the more accurate our line is going to be. So if the points are all over the place, we may be able to come up with an equation, but it may not be super accurate. But if all of the points are together, then we're going to have a really accurate time of getting our equation. Generally, the strategy that we use is we pick 2 points from the set of data, and then we solve for the equation between them, just like we were doing when you were given only 2 points. The difference now is we have to pick 2 points, so we need to find 2 points that are sort of in the middle of where we think the line is going to be. So right here, we've got the graph that we were looking at in the last example, and we need to go ahead and pick 2 points for where we think our line is going to be. Now, if you notice, if I pick these 2 points in the middle here, if I pick those 2 points, my line is going to be looking like this. And that's not very accurate for where most of the line would be looking. It's going to be more something like this right here. So I'm actually going to pick the first point and the last point right there. So I'm going to pick this point down here and then this point up here. And the values that I have are 1940, 23, 100, and also 1980, 89, 300. Well, even though these are really big numbers, these are exactly the same as 2 points that we had been working with when we were trying to find the equation for a line. This is x1 and y1, x2 and y2. So I'm going to go ahead and solve this out the same way that we've been doing. So I'm going to subtract my 2 y values on top and subtract my 2 x values in the bottom of the fraction. So you may want a calculator for this part. You should get 66,200 for your numerator. And then 40 for your denominator. And if you divide this out, you get a slope of 1,655. Now I'm going to move this slide out of the way. Make sure you have this written down because we're going to continue this problem and finish this out on the next blank slide here. So as we just found, we've got our 2 points for starters. We've got 1940, 23, 100, and our second point was 1980, 89, 300, and our m, as we just found, was 1655. Like so. Now, I want to plug into slope-intercept form. So I can find my b, my y-intercept, I can use either of these 2 points. Either one will work. I'm going to choose to use the second point. So this is y equals mx plus b. What we've got here, we plugged in our numbers. Now we're just going to go through and solve for b. Once again, calculator would be very helpful with this. So 1655 times by 1980. My calculator seems to have died on me. For your problem, go ahead and finish this. Finish solving this out, and we will talk about it in class.